So for today it's a lab day, but I'd like to talk a little bit about what this lab's about, and then also show you a couple things that will kind of help you with the lab. There's some step-by-step instructions that cover most of what I'm going to show you, but sometimes it helps to see it in kind of a fluid action. Plus, I'll record it for you. You can look at it on Integrity. Should you want to review or be like, what did he do there? So, like I said on Wednesday, part of this lab is going to involve using Model Builder, partially as a cartographic modeling tool. So you remember cartographic models have, you put your data layers in one shape, right? Connect that to some other shape, which is a process, and then you have your output layer. And your output layer can then be the input to another process, etc., until you get to an answer, right? Of course, what did we find out the other day when I brought it up? At least on my laptop, the model builder had inverted the symbology. Doesn't really matter. Square is a circle is a square, right? So, but that's a cartographic modeling technique, because you fill this in, right, like this. DEM, slope, and maybe you want it to be percent slope. Leads to slope map, right? And then maybe we run reclass to get only those places that have high slopes, right? Above 15 degrees, right? Or maybe make this degree slope. And above 15 degrees. And then we have our suitable area. Make sense? Especially if you check out some cartographic models online, like go to Google image search and type in cartographic model in quotes. You see a couple examples. So for this lab, you're actually going to be working with data for the continental United States. And this data layer is available in a geodatabase. It's up on Blackboard right now. And it's in a zip file, so you have to extract it, connect to a folder, etc. Anything you notice about this CONUS file? It's up here, we're looking at it. Anything strike you about it?
It's kind of stretched like that.
Yeah, it's kind of a little distorted, right? Like, we're not used to seeing the northern boundary of the western United States as a flat line. And that's just because this is in a geographic projection. Really, though, looking at this, that's pretty much the only thing you can really divine just by looking at the display, right? So it's not, at least at first glance, anything special about this data set. I think I've shown you this before, but it's worth calling attention to. You can reproject data, change the data's actual spatial reference and projection by running a tool, and that actually modifies your data set pretty significantly sometimes. If you just want to change how the data are displayed, you can do that as well. And that doesn't change your data, but it changes the projection of your data frame, your data display, right? And so to get to that, you can just double click on layers here. And we could pick a predefined projected coordinate system that maybe is something that we're more used to seeing, right? Like maybe I'd pick the Mercator projection, right? Suddenly the United States looks a little better, or a little bit more like we're used to seeing. There are a bunch of them, and actually this is a neat way to play with projections, because you're not changing your data, it adjusts your data pretty quickly. But that's not really what this lab is about. What this lab is about is answering questions with attribute data. Okay, and so you've got this big data set here, and if you open up your attribute table, you'll notice that there are a lot of attributes, mainly dealing with demographics. And then over here on the end, oops, I got back to the beginning. There are three. attributes that you're going to focus your lab efforts on. Two of you have had this activity in a similar case. You're going to need to choose a different variable from the last time. Okay. Just FYI for the two of you that applies to. But the lab's a little different this time. So one of these columns is endangered. What do you think that might mean? We could display it as a map even. Check it out. Endangered. Yeah, endangered species. Right. That makes sense because usually we don't talk about endangered Best Buy locations, right, or something like that. I don't know what endangered Piggly Wigglies. Right, I'm trying to think of what might be concentrated in the United States in a distribution like this. Kind of hard to come up with it. I don't know, endangered soda machines, right? So that's one of them, endangered species. Another one is state GDP. Anyone know what GDP means? Yeah, everyone should know what that means, gross domestic product. And so basically it's showing you the amount in some units. It's not dollars, it's some multiple of dollars, okay? And you'll have to figure that out, which you can do using the metadata that's available with this layer. And, you know, it shows you basically the amount of economic production that each state contributes to the overall GDP for the United States, right? Although it's not a proportional measure, this is an absolute measure of how much economic value is produced in each state, okay? And then the third one is flu. This one's a weird one. If you look in the metadata, it will describe it a little better than I probably will. But in this case, well, look at the distribution. What strikes you with this distribution? So flu is just influenza. What's weird about this? Or what can you observe anyway? It's not really anything necessarily weird. Do we have some states that are somewhat sickly? Yeah. What would your stereotype be, though? Is flu more likely to be a problem in states that are cold or hot? Stereotypically, what do you think? Cold. Some people are saying cold. Some people are saying hot. Right. The stereotype is that typically, anyway, and maybe it's not this way for everybody, but in colder places, you've got to deal with colds and flu more often because, I don't know, they suck, whatever it might be. I think maybe the argument goes you spend a lot of time indoors in close proximity to other people, and the cold brings your immune system down. Fact is, the stereotype, that stereotype anyway, isn't really supported very well by the data. Which we've got one state that might be considered cold, right, with a high number of, with a high value for flu, right. Otherwise, it looks like the South really has a worse problem with the flu. Right? Now, there are a lot of reasons for why that might be the case, and actually, it's not absolute number of flu cases that we're seeing here, and this explains some of the variation that we're seeing that kind of runs counter to stereotype. Actually, what this is the number of, it's something like the number of months of flu, above normal flu reports, right, over a 24-month period or something like that. You have to look in the metadata. But it's a shorthand measure for flu intensity. What that means, though, is like, you know, if you live here in Louisiana, your more high numbers of flu happen more, or more flu intense months happen, right? It doesn't necessarily mean that more people get the flu. could just be that a lot of people get the flu a lot of the time, rather than a ridiculous number of people get the flu for 2 months a year, right? So anyway, so those are the 3 pieces of data that you have to work with. And you're going to use these data to derive new data. Derive new data like, what would be a good way to derive data from GDP, knowing that you also have a bunch of demographic data to work with? Do folks usually talk about gross GDP? Usually hear that? Like, Somalia's GDP is $30 million or whatever it is. Usually we hear about things like GDP per capita, right? So that would be one way to derive a new measure. What are you doing when you do that? Well, you're evening out. Obviously, places with more people are probably going to have more economic production, because for the most part, economic production depends on labor, right? Although that's changing. So you would think a more populous state, right, like New York or Texas, would have higher GDP overall, right, than a state like Maine or Montana, right? But it could be, it conceivably could be that GDP overall, if you divide it by the number of people, the economic production of a place is much higher on a per capita basis, meaning that its citizens are perhaps more productive. A good example of that is in Europe. There's a nation of Luxembourg, which is very small, has a very small population, but massive economic wealth is generated there, right? Mainly through banking. Okay, so those are your three data sets, or your 3 data variables. And the lab walks you through the normal clicky way of deriving data, and it does so by walking through a process by which you add a column, which is called a field, right? And that's pretty easy to do using the kind of just normal interface tools here. If my laptop wouldn't freak out. This is a new one. I've never seen it do this. Time to take a sip of coffee. Okay. I might have an ArcMap crash going on here. Anyway, well, that's okay. I'm gonna close this and restart. My apologies. So while this starts up, I can show you one way to learn about the data set is actually to open up Arc Catalog, the standalone application. It's in your ArcGIS menu in the Start menu. And you can come here to the folder you have it stored in and click on the layer and click on the Description tab, and it'll give you a lot of information about the layer, including stuff like Esri fields, right? Check it out. If we come in here, state name, the state name, FIPS, the FIPS code for the state, right? And it tells you who's responsible for it, what it means. You know, POP 10 square mile, the 2010 estimated population of the state per square mile, right? So this will give you a good idea of perhaps what some of the measurements are in other categories. Like you might not know what AVG size 07 means. It's the average farm size for that state, right? All right, so now this is back open. Okay, so we have, I'll add the data back in. Slow. Add in CONUS. And then the normal clicky way where you'd add another attribute, well, okay, what we want to do is derive a new attribute from the existing attributes, right? Well, to do that, we need to create a new attribute. But unfortunately, it's not a super streamlined process. You can't just say, ArcMap, make me a new attribute and make it this. We have to make a blank attribute called something and then populate that attribute with values, essentially. So the clicky kind of user interface way to do this is to use this little menu up here and go to Add Field, select an appropriate data type, okay, and then maybe I'll call it pop dens, even though the population density is in there. This is one that's pretty intuitive and easy to calculate given the data that we have here. Okay. So now notice that I have a new column at the end of my table, and it's full of null, meaning nothing, right? And literally all I have to do to calculate, to populate with values is to use the field calculator tool here by right-clicking on the title. And then I can set up pop dens, right? Pop dens equals, I can say take population 2010 and divide by square miles, right? And what's that going to give me? Population density, the number of people per square mile. All right. Click OK, and in a moment or two, my column should have some new values put in it. So check it out. If I click on this line, make it blue, and then show my map, it looks like Washington State has a population density of 94 people per square mile. Right? Seems high, but there's a lot of Washington that's pretty highly urbanized. Right?
Do we have to set the unit by ourselves, or is it going to be set up the unit like population per square mile?
You will have to set that up yourself.
Oh, okay.
Right? You'll have to come up with it. And there are a lot of good ratios, for instance, to develop out there. Like, GDP per capita is a good one. Or, number of people per farm, right? Or number of farms per person. Right? That would be an interesting thing maybe to put in there. What do you think? For endangered species, for instance, is it important for, what would be less impactful for an endangered species, a farm or a city? It's hard to say, right?
Depends on the species.
Yeah, it does, and depends on what type of farm, too. Like, depending on the state, a tree farm could be listed as a farm. And tree farms, if you've ever been to one, a lot of times tree farms are basically somebody who promised not to cut their trees down for 30 years. Right, so that would probably not have a huge impact. So anyway, there are a lot of different things you could do. You could take 2010 population and subtract the 2000 population from it, or vice versa, and come up with some way of measuring rate of population change. Right, that would be a pretty interesting thing for almost all of these variables. Could be that if you have a state with rapidly growing population over a 10-year period, you're more likely to have flu because public health infrastructure hasn't caught up with the demand, for instance. I mean, there's all kinds of things. You might see GDP. That might explain why GDP is higher in one state than another. All kinds of stuff. Right. So anyway, that's pretty straightforward, right? Well, remember what I said on Wednesday. Almost anything you can do clicking around in ArcMap, you can do in Model Builder. So I wanted to go through how Model Builder would work. Here's the Model Builder icon up here on the toolbar. Right here. Right? This thing. And if you click on that, it'll bring up the Model Builder window, and it's pretty nondescript when you first start it up, right? It's pretty much empty, nothing going on, and that's because you're the person, you get to populate it with data and processes, right? So you can use the Add Data window, and you can add data or tools using this, or Add Data tool, but it's kind of inconvenient because to search for tools, you have to go into toolboxes, etc. It just becomes kind of a little bit onerous. So instead, I tend to use a click and drag sort of way of interacting with this. Incidentally, to make this fit the cartographic modeling kind of standard, you might switch this to style 2, right? And that puts data in boxes and processes and circles. It's a little bit more appropriate, but it's not totally necessary as long as you can keep them straight, right?
How did you just do that? How did you just do that?
Go into Model, and then Diagram Properties. Okay. All right. So I got my data there. Now, what would be the next step? So my data's in there. That includes the shape, the geography, and the table. They're kind of a package deal. So what was the first step of what I did before? We're just going to replicate that same variable.
Search the attributes.
Yeah, add a new attribute, right? And that was called add field. Well, unfortunately, I can't like drag add field from that menu item in the table. Actually, I've never tried that, so why don't I try it? I couldn't do something like this, right? Take add field and drag it over here. Nothing happens. But if you use the little search feature here to search for the term add field, right? Search for it, a bunch of stuff comes up. And in your lab, I tell you that the actual add field that we want is actually the one that says data management, right? But I can just click and drag it here and it pops up. So now I have my data and I have the first tool that I need to use. What's the problem right now? Yeah, they're not connected. So we can use this connect tool, right, to connect CONUS to add field. And you'll notice it brings up this list here. And in this case, you can just select input table. There are other things going on. One, you could have a variable or a data set in there that sets the analysis extent or mask, right? Or if it's a raster data set, you could say, this data set is the cell size that I want all analyses to be based on, right? Or you could set a precondition, which is basically the model cannot run until this condition is met, right? But we don't really care about those things for this lab, so you'd say input field. Now, it's connected, but we still couldn't run this to add a new item. We have some missing things. Notice how the tool here is white, right? That means it's incomplete. It's missing something. And so if you double click on add field, this add field dialog box will come up, which incidentally looks exactly like the one that you would find in the search tool if you clicked on add field. Same exact tool, right? And it looks like we need something called field name. And if you notice, I click in it, and over here on the right, this will actually tell me in brief what that means, right? Field name, the name of the field that will be added to the input table. Oh, pop dens, right? Field type, so this is data type, and because this might have decimal points, I'm going to call it a double float. I probably could get away with long up there, or maybe single float, but just so that I don't get an error. There is a question about data types in your lab, and I give you a resource that you can use to refresh your memory. It's also discussed in the book. But the way the book talks about data types and the way Windows addresses data is slightly different. So your book will talk about floating point, but in Windows you can have different levels of floating point data complexity. Okay. And then nothing else is necessary, and in this case, don't worry about it. And notice my model, the color's filled in, right? That means that it's complete, and those tools could be run. So what's the next step? So we add that tool will add a field. What do we need to do next?
Name the field.
We need to populate the field, yeah, because the field's named it when we wrote pop dens.
Okay.
Yeah. So and again, we can't just use that field calculator, but let's search for calculate and see what comes up. Well, there's a bunch of tools here, right? Calculate polygon main angle. Does that sound right? I don't even know what the heck that is, right? Raster calculator. No, not raster. What about like calculate value? Maybe. Let me click on that and see what it says. Or value tool returns a value based on a specified Python expression. Python? That doesn't sound right. It's actually this one. Calculates values of a field for a feature class, feature layer, raster catalog. So there's a little synopsis there. And if you're really confused, you can open up the tool and then go to tool help, and it'll give you in detail a description of what is going on, right? What that tool does, right? It'll even give you examples. In this case, though, I'm telling you, it's definitely this calculate field, and again, we can just drag it over there. We'll have to connect it, right? And what are we connecting to what here? Yeah, we're connecting the output of the add field process, right? And we'll make that the input table. Why wouldn't we just draw a line from here to there? It would let us, but we'd have to calculate the value of a field that already exists, so we'd be overwriting data, right? So the output of this tool added a column, and now we want that output with the new column in it to be the input for this calculation process. So again, you can just double click on calculate field, and then you have to pick the field name, and notice all of the fields, all of those attributes from that data set are listed, and if we scroll down to the end, the one that we're going to add is in there, and then we just need our expression, right? And it's just like the field calculator. We can put in pop 2010 divided by area, right, square mile, and go ahead and click OK, and we're good to go. And we can run this process. Click run. That didn't take very long. Notice it'll tell you what it did, right? There's the add field information there. Oh, now it's calculating values. Here's the expression, and it's done. It took it 0 seconds. I don't know if I believe that. Okay, so let's see if it worked. Open up the attribute table, and remember, I deleted the old one. Oh, why did it only work on one? Any ideas? It only worked on the one that I had selected, Washington. It's both a frustrating and incredibly useful aspect of ArcMap. Frustrating because you can inadvertently do what I just did, right? Select a state, and it'll only run your requested analysis on the selection. It's also really awesome because let's say that you had your 48, continental United States, and you knew 3 of them had an error, and you needed to recalculate the value for those 3. You could select just those 3 and run the same tool, and it would fix just those 3, right? So in this case, it's because I had that one selected. So if I clear it out and rerun my model here, I guess it won't let me run until I reset. Or maybe until I delete this field. Okay. Oh, another thing to point out. If the model has run a piece of it already, it puts a shadow underneath the tool. So close. Let's see if it worked this time. Yep. Here's all my data. Right. So what you're going to do is you want to step through the process of adding a field and calculating a variable at least once in the clicky way in the table, just so that you have an idea of how that works. But for this lab, you're going to set up your variable creation is going to be in a model, okay? And you're actually going to submit that model to me in addition to your lab report. Let me show you a couple aspects of that model building and saving and running process that'll make your life a little easier. First of all, so you're going to save this model and upload it to me on Blackboard. In the week 10 folder, there's already an upload spot for the model. Problem is, if you click save here, okay, and let's say I go to my folder, I can't just save this model here. It says an error occurred, right? And that's because models have to be saved in toolboxes. Why? Good question. I don't know why they couldn't just have models saved as model files. It's kind of annoying. So you're going to have to, in a folder where you know the location of it, probably a good idea would be to save it in the same folder you write your lab report in, or you store your data for this lab in, right? You actually have to create a new toolbox, and there's a little tool for that there. And you want to call that toolbox, right? You don't want to delete that .tbx at the end, right? You want to call it your last name, except actually your last name, okay? Lab4 toolbox. And then you can double click on that and save your model, which you should call your last name, Lab4 model. And now it's saved. And now any changes you make to it, you can save it to that toolbox, and that's great. So then if I close this out, how do I reopen my model? Could I go here to Model Builder, go to Model Open? Crap. Yet again, needlessly complicated. Instead, we have to expand our toolbox here on the side, and if it's not on the side of your installation, you can actually open it by clicking on this little Arc Toolbox icon, or going to Windows, and I guess not in Windows. Yeah, anyway, this icon right there, okay? And then you'll want to right-click on this top Arc Toolbox thing and go to Add Toolbox. Find the toolbox you just created. I happen to know mine's in the C Steve folder, and there it is, right? And go ahead and click Open, and you'll find it'll show up alphabetically. So like if I put it Aldrich Lab4 toolbox, it would have been up here right after 3D Analyst. And then if you expand it, there's your model, right? So you double click on it and you get this crap. Instead, you're going to want to edit that model, right? So you right click on it and go to edit. Needlessly complicated, but it's there and it runs and it's saved. Okay. Next little thing, when you upload that to me, I want to show you what this looks like from a Windows perspective. Let's go to my C Steve folder, and I made a your last name toolbox. There it is. That's the file that you'll want to upload. Notice it's not associated with any file. If I try to run it, it tells me it can't open this file, right? Because it's some weird thing Windows doesn't have registered with it, right? You register file types and Windows doesn't know. So, you can't double click it to add it to ArcMap. You might be able to drag it in here. I don't know. I've never tried that. Maybe. Could not open the file. Anyway, there's the toolbox file. That's the file you upload. And so it's a little bit convoluted to like stop your work and start again, but it's not ridiculous, right? Well, it is ridiculous, but once you know the process, it's somewhat straightforward. Okay. Any questions about this? The lab write-up is the same as it's been so far. Right? One other thing I forgot to mention. also as part of this, you have to come up with what I call a conceptual model. So let's say that I've decided I'm going to work with the GDP data, and I want to explain the spatial relationship of GDP, right? And so I map my GDP data, and I notice that and I can do that right now. Right, let's just map out raw GDP data. My beautiful map right here. So my hypothesis, maybe I look at this and I'm like, okay, well, high GDP states, we've got New York, California, Texas, Illinois, Michigan. We've got these states are like second tier. What's common to all those states? Just looking at it.
Cities?
Yeah, population, right? So my hypothesis is something like this. My conception of the relationship between of why GDP is distributed this way is that GDP and population, right, lead to the spatial distribution of GDP. There's nothing else, right? I could bring in a third variable. I could say, and low farming, right? I could say like farms, whatever it might be. That's a conceptual model. You're just showing how they relate and maybe making a formal statement about your hypothesis. So you could do that digitally, and if you do it digitally, it's due with the rest of your lab report. If you write it on a piece of paper, totally acceptable, but you have to give it to me during class a week from today, which is when this lab is due. Okay?
Can we just scan it and attach it?
Absolutely. Or stick it into your Word document or whatever as a, an inserted image. I mean, you could upload it as a picture, send me a link to it, post it on, Flickr or Photobucket or something like that. Totally up to you. As long as you get me some way of getting your scanned image. Or you could write, make your conceptual model in the flowcharting capabilities of Word or whatever. Although my experience is that takes way longer than it should. Questions? Okay. Concerns? It's okay to be. That's Lab 4. Your concern right now is Lab 4. Okay. Trying to think if there are any good tips to hand out on this one. I would say keep your hypotheses somewhat simple. It's totally acceptable to have the two interacting variable hypothesis here, right? You're trying to explain a spatial distribution. Probably, right, in this case, we're talking about GDP. Probably the major reason is population. And I'm saying that, it's not because, right, population's so super high in New York, but the history of population is that it was super high in New York, right? So you have high population, you typically have not only an increased need for goods, which drives economy, but also a nice right labor force, which drives economic development, which means that you have big companies building there. That's what's driven Michigan's kind of second tier status, at least in this classification of the data, right? What's going on in Detroit right now? Big census news. It lost like a huge number of people. Population declined since 2000 there. But Michigan still has one of the higher GDPs in this country, right? Because why? What gets built in Michigan?
Cars.
Yeah, cars, and that's a big chunk of our economy. Fewer cars get built there now, but yeah, it's a big chunk of our economy. Plus, it also has a big agricultural sector. Right? So, kind of a 1-2 punch there. Illinois, why is that in that second rank? Got the second biggest city in the country, right, Chicago, major banking center. Also has a fair amount of industry. What's going on in Florida? I mean, no offense to Florida, but if you've ever visited Florida, most people probably have. You visited Florida, super highly industrialized, super technology focused, super agricultural. A little bit. They grow oranges and sugar, right? Why is the GDP big there?
Service.
Yeah, service sector, especially healthcare, right? And tourism. So, it doesn't have to be just industry or agriculture. But, anyway, and then, looking at things like, let's look at some of these other variables. So looking at flu, we kind of looked at flu. Let's look a little bit more at endangered. So California tops the list big time. Why would California have the highest rate of endangered species? This is just number of species on the endangered species list. California has 308, I think.
Is this based on state classification or federal?
Believe it is federal. State? No, it's state. No, it's federal classification. This is Fish and Wildlife Service data. Good question, though, because the state can call something endangered, and the feds can be like, nope. Vice versa, too, incidentally. Notice any spatial trends here? Like California's at the top of the list. If you go to California, can you find desert? Yes, right? If you go to California, can you find rainforest-like environments?
Yes.
Yes. If you go to California, can you find like a Mediterranean-type chaparral environment? Mm-hmm. Yes. If you go to California, can you find a deciduous temperate forest environment? Yes. If you go, can you find grassland? Yes. It's very diverse, right? And so that means there's a lot of habitat. Of course, if you go to California, can you find massive urbanization? Yes. Can you find massive military bases? Yes. Can you find intensive agriculture pumping water out of the ground at an insane rate? Yes, right? So the human modifications going on in California are pretty significant as well. So you kind of bring those two together, and it's kind of no wonder almost that California has a high rate of endangered species, or a high number. What about a state like Tennessee, Alabama, Florida? What about these states? They're in the next category down. Why would Tennessee be on that list? You got like Nashville and Dollywood, right? Well, Tennessee, running right on the east part of it, you've got the Appalachians and some of the most biodiverse forests east of the Mississippi, both in terms of tree species, but also amphibians. And you got like more salamanders in the Smoky Mountain National Park, which is here, right, than anywhere else on Earth, for instance. And almost all of those are endangered. So even though Tennessee doesn't have an awesome history of environmental protection and preservation, it does have a lot of natural wealth. And there's also a lot of development, right? A lot of highway-based development. There was also big investment during the buildup of nuclear materials after World War II. That's where there's that huge uranium processing plant that's basically a nuke waste site now. Nobody can go into it or near it because it's just that contaminated. Right, that's in Tennessee. Right, so there's a lot of endangered species there. Texas is an odd one for me, but again, you've got a massive area with lots of different environments. not quite as many as California, and massive development, right? So you end up with a pretty interesting thing. Why is it that like the Dakotas, Minnesota, Michigan, Maine, all those M states, right? Pennsylvania, why are these places pretty low on the list? Most rural state in the country. Some of the coldest states in the continental U.S., right? No development of any kind, essentially. I'm being a little facetious, right? All the way across here. St. Maine, literally only south of my hand do people live in Maine. And I'm pretty much not exaggerating. Pennsylvania, basically here over, lots of people. Here over, not really so many. West Virginia is weird. I'm surprised there's not more. Why do you think? I mean, because in West Virginia, right, they're blowing up mountains and dumping them into valleys for coal, right? It's also in the Appalachians, so you've got a lot of different environments in West Virginia. So there's pretty good biodiversity there, actually. Why so low on the list? Poor West Virginia. I don't mean to pick on them, but I'm going to. Yeah, they deliberately don't have laws to protect very many species, so they don't list very many. Right there, it's much harder to get a species listed on the list than it would be in a state like Massachusetts, right, or California. So anyway, you got to think about these things. There's reasons, sometimes multiple reasons, right? They're not, but it's okay to just pick a one variable driver in this case for this lab. But you got to do two. I think is the parameter. You got to create two new variables, working with what you have. All right, I can let you go unless you have any questions or concerns or issues. Okay. Yeah. But I went over it.
So, just save button here.
Yeah, but you're in a toolbox right now, right? So you can go up a level. Yeah, like go to your folder.
Yeah.
And then now you set the toolbox. Okay. And just don't make sure you don't get rid of the .tbx. Okay. Or else RGIS. What are you trying to do? Okay.
Thank you.
You bet.